Hi, welcome back. In this tutorial, we'll see how to create a vector in R. To create vector, what is vector? Vector is just a placeholder of a similar type. For example, placeholder for a list. Placeholder for like an integer value or a decimal values or like a similar type, or it can be a placeholder for a strings value like a names like John, Mary, something like that. So let's see in action how to create it. I think we'll get a better understanding. So we have a so again with that. So to create a vector, we do C for integer, and then we say 1, 2, 3, 4, 5. Okay, let's do 6. So here we see. So if you want to see this, what's in R? So we see it's created a variable x, but it's actually as vector. It holds a lot of values. We can also, there is a multiple way we can do this. So for example, we can also do y 10, let's say 100 to 600. And we see it's created the values from 100 to 600. And it's a lot of values, right? And if you want to just do override, so let's do 10 to 60. And now if I do y, it's only shows 10 to 60, and also it shows it's overridden the value without any complaining or something. Let's say now we have, there is another way we can do this. I'll keep using the same variables sequence. It's also very handy. So it says let's start with 10 and we go 60 again. Okay, actually let's just do this. So this is the syntax for it. So it says first the sequence is from 1 to some value. So we want to go from 10 to 60, and then what's the increment by what, right? So we say we go 10. So we expect the values to be 10, 20 something. So you see, so it's get created 10 to 60. Also we can do some, let's say for some operations on this one. If you want to want to increase the value, make a, let's say square all the values of x, so we can do again. So it's similarly when we do on 1 or it doesn't matter for R. So now we see the values of it goes from 1, 2, 3, 4, 5, 6 to the square values, but actually we didn't, if we see we not store it, we just do the calculation here just to represent, but actually the storage is not there. If we do something like this, here it's stored. We don't want to do that. So what about if you on the y we want to do square root? Again is a similar concept. It's square root, showing the square root. So rather than 1, we can also do x times, let's do x plus x plus y, not times. So here we see it does the plus. I just want to mention one thing here. As we see the length of x 6, and length of y is also 6. So when length and y is same, so it does each value. So this one, so let me show you again. So x and y, so what is x? X and y, right? And then we did this sum. So what happened? Let's say now it shows that. So first value sum with this, second value sum with this, third, fourth, and so on. So this is the case. So let's make it sum. Okay, so we did sum when both vector length are same. We just show it here. We can do other operation as well, but just for example, what if the length are not same? Sum when length are not same. I'm writing this comment, so I will put in description for you as well if you want to try and easy to follow. So let's try. We do some another one. Let's say z. We only have, let's say, 10. Okay, let's create like this. Only two values. Let's say we have 100. We use 100 for y? No, we use 10, 20, right? Okay, yeah, that's good. So we use 100 and 200. Okay, let's make it 300 as well. Okay, now for z, length, if you see again, which we know is 3, now we sum z and x. So let's see what happened. So x plus z. So we see here, let me pull x here as well, so it's easy to see x and y, and then what we did this. Okay, now it is 3. So our x was 1 to 6 and our our z was, right? Yeah, and then we did this. So basically what it does, it's first one it adds to first 100, 1 to 100, 2 to 200, 3 to 300, and then does we have z value, and then it's for 4 it sum up with z again, 100, 200. So it picks, when it finish it picks up the value again. It's 104, 205, and 306. So that's how it works when this is not same. Okay. Oh. So this is to do some operations. This to create and do some operation. We can also actually do multiplication. It's pretty much the same thing, x and z. So multiplication, we can divide. Okay, let's do x and z. We did multiplication here. Okay, let's try x when it's same x and y divide. It's nothing really matters. It's the same concept, so it's like this. We can also do log on x, log on, let's say do on y. Is this? Okay, so hopefully you don't mind me typing up and down. So that's the beauty here, right? So I can save this file and put in the description. So that's why I'm doing this, but and also it shows that where these are the individual operation. This is we do together when they are both same and they are not both same. Quickly, I can also show you how we can, let's say if we can do this. So here you can see is a combined value in a list or a factor. This is to show you as a help. You can just highlight this one because it's only one, and then just press F1, so it's the list. It will open up the help for this one. So this is for a vector. In okay, so this is a generic function basically is combined. So the default value combined is to form a vector, and all argument are coerced to a common type, which is a type of a return value and attribute the same name. And also, if you want to follow some example and explore more, you can do more as well. This is quite handy. Okay, thanks.